Welcome to Rubia's Tech Talk. As continuation to the previous video, we've derived the torque equation of a three-phase induction motor. So now we are going to derive the condition for maximum torque, and also from that we are going to find the magnitude of the maximum torque value. Okay, so let's start the derivation. So condition for maximum torque in a induction motor. Condition for maximum torque in induction motor. So already we derived the torque equation as torque which is equal to K into S into E2 squared divided by R2 squared plus S squared X2 squared. So this is what the equation we derived. This is the torque equation at running condition of a three-phase induction motor. So this is the torque equation during the running condition of a three-phase induction motor. So what will be the torque value while the motor tries to start or at the starting condition? So that is what we are going to now substitute. So at starting, what is the parameter which is going to change is at starting, okay, in an induction motor, I will be having the formula for slip which is equal to Ns minus Nr. Okay, at starting my Nr equal to 0. This Nr will be equal to 0. Why this Nr is 0 is I am just giving the supply to the three-phase induction motor stator. So because of the mutual induction, I will be getting because of the Faraday's laws of electromagnetic induction, I will be getting a rotating magnetic field in my stator. So the magnetic field which is produced in the stator will be rotating. Okay. So that rotating magnetic field will be having a speed of Ns. So this Ns which is given by the formula 120 F by P. So what is the scenario? At starting my Nr is equal to 0. So if I substitute my Nr equal to 0 in slip percentage formula, Ns minus Nr by Ns. Okay. So my Nr is equal to 0. So I will be getting Ns by Ns which is equal to 1. So my slip value will be equal to 1. So this is the maximum value. Okay. The slip value will be always less than 1. The maximum value of slip is S is equal to 1. This is the maximum value. So what is the condition we are going to substitute in this running equation is, running condition torque equation is S is equal to 1. We are going to substitute S is equal to 1 in the first equation. Okay, substitute in first equation. So what we'll be getting if we substitute S is equal to 1, torque which is equal to K into E2 squared divided by R2 squared plus X2 squared. So this is what the torque value or starting torque value. Okay. So during the time of starting, my torque will be getting the equation as this equation. So this is my torque equation during the starting condition. Torque equation of a three-phase induction motor during starting condition. So during running condition, I will be having torque which is equal to K into S into E2 squared by R2 squared plus S squared X2 squared. Here I will be having torque which is equal to K into E2 squared by R2 squared plus X2 squared, since we are substituting S is equal to 1 in the first equation. So from this starting condition, we are going to derive the condition for maximum torque. Okay. So from the running condition equation, we are going to start with the condition for maximum torque derivation. So condition for maximum torque. So K torque which is equal to K into S into E2 squared divided by R2 squared plus S squared X2 squared. So now I am going to do the partial differentiation dt by ds. So what is the formula I will be getting? V into du minus u into dv divided by v squared. So R2 squared plus S squared X2 squared into differentiation of E2 squared into K2. s into e2 squared into k2 minus k into s into e2 squared into differentiation of r2 squared plus s squared x2 squared divided by, I need to go for r2 squared plus s squared x2 squared the whole square. So this is how we are going to derivative or calculating the derivative, determining the derivative of the torque equation from the running condition. So what we'll be getting is, we'll be getting r2 squared plus s2 squared x2 squared into k into e2 squared r2. Because while we are differentiating with respect to ds, here the s which will be taking a value of 1. So remaining parameters are k into e2 squared into r2. Okay, minus again k into s into e2 squared into, if I am differentiating this r2 squared with respect to ds, what I will be getting? I will be getting 0. So this s squared, what form it will taking? So it will be written by the formula 2s into x2 squared divided by r2 squared plus s squared x2 squared the whole square. So in continuation with the previous derivation, dt by ds, which is equal to, what is the equation we are getting? r2 squared plus s squared into x2 squared into differentiation of k into s into e2 squared into r2 minus k into s into e2 squared r2 into differentiation of r2 squared plus s squared x2 squared divided by r2 squared plus s squared x2 squared the whole square. So this is what from the running condition equation we've just substituted in the formula v du minus u dv divided by v squared. So now we are having dt by ds in the LHS side. So the first part, a part, will be directly writing. So r2 squared plus s squared x2 squared. So what this parameter, this formula will be taking a new form, like I am differentiating this portion with respect to ds. So this s will become 1. So I will be having k into e2 squared into r2, right? Okay. Now in the next equation, like minus k into s into e2 squared r2, I will be directly writing. So while I am differentiating this portion, this r2 squared will be taking a 0 value because this r2 is constant with respect to s. So it becomes 0. So this s squared will become now 2s into x2 squared. Okay. So divided by r2 squared plus s squared x2 squared the whole square. So now this denominator portion I am going to equate it to 0. So dt by ds, if I equate it to 0, what will happen? r2 squared plus s squared x2 squared into k into e2 squared r2 minus k into 2s squared k into 2s squared into e2 squared into r2. So this will become 0 and now this parameter will be multiplied with the 2s into x2 squared. So I will be having here x2 squared. Okay. So in the denominator portion I will be equating to 0. So now again I am multiplying this r2 squared with this portion. So r2 squared into k into e2 squared into r2 squared plus 2 into k into s squared into e2 squared R2 x2 squared minus k into 2 s squared into e2 squared r2 squared x2 squared minus 0. If you see carefully the equation, this is having the number as plus 2 and this is having the number as minus 1. So now I'm going to subtract this part and this part. So what is the final part? I'll be getting k into e2 squared r2 k into e2, sorry, here I'll be getting r power 3. So k into e2 squared into r power 3 plus k into s squared into e2 squared r2 x2 squared equal to 0. So here I'm having 1 for this k into s squared into e2 squared into r2 squared x2 squared. The number or the variable which is common, but the only part is the number which is going to have a different value, here as 1 and here as 2. So if I do minus 2 plus 1, I'll be getting minus 1. So here from the next step, I'm going to take the common value as k into e2 squared into r2. This is the value, I'm going to take it as common. So what is the remaining part? I'm having r2 squared plus, sorry, minus s squared x2 squared equal to 0. So this is the part after I'm taking a common value k into e2 squared into r2 for these two variables. I'm finally getting this equation. So from this equation, I come to a conclusion like, again, since this LHS is, which is equal to RHS 0, I can write this as R2 squared minus S squared x2 squared equal to 0. So again I can write this R2 squared which is equal to S squared into x2 squared. Then from this I can come to a conclusion as R2 which is equal to S into x2. So this is what the condition for maximum torque. So from this I can write the equation in terms of slip. So slip S is equal to R2 by x2. Whenever my rotor resistance and rotor reactance are taking a value which is equal to slip value, so this condition can be claimed as the condition for maximum torque. Condition for maximum torque in three-phase induction motor. Okay, so this is the condition, or this till this condition I can load the machine so that the machine will take the load and run with the respective speed. So after this value, after the condition of S is equal to R2 by X2, if you try to load the machine, the maximum torque value will be pulled out and the machine will comes to a stalled condition or the machine will stop. So this is what the condition for maximum torque value. So we'll see a new topic in the next video. Thank you.